Okay, here we're going to be starting our unit on radicals and how to simplify radicals and square roots, perfect squares, and whatnot. And our first one here says find the value of each of the following. So here we're looking at the square root of 25. 25 is a perfect square because 5 to the second powered is 25. So the square root of 25 is 5. Looking at number 2, number 2 says the square root of 169. Well, 169 is actually 13 squared, so therefore it is 13. And number 3, this negative side is separate from our radical, so he's just going to be hanging out here to wait and see what comes out of the radical. 441, well, we know it's greater than 20 squared, so we can go here and test and see. I have 21. Let's try it. So we multiply 21 times 21, and in doing so, we see that's 441. So the square root of 441 is 21. Now with number 4 here, this 2 is going to be over here chilling, waiting to see what happens with my radical. So I say, what's the square root of 144? Well, 144 is 12 times 12, or 12 squared, so that square root of it would be 12. Now I multiply 2 times 12, so I have 24 as my answer. And number 5 here, number 5, again, the negative is just going to be out front chilling. Whenever you have a fraction like this, you can think of it as the square root of 1 over the square root of 64. So the square root of 1 is 1, because 1 times 1 makes 1. Square root of 64, well, that's 8, because 8 times 8 makes 64. So the square root of 1 over 64 is 1/8. For number 6, the same type thing. You take each the numerator and the denominator separately. The square root of 169 is 13. And the square root of 225, well, that's 15 times 15, so that would be 15. Looking here at number 7. This time we do have a little extra work we need to do with it. This 3 is going to be chilling out front, waiting to multiply by whatever comes outside of the radical. Well, the square root of 361 is 19. 576, we know it's greater than 20. So we'll start going along thinking, how about we try, let's test 24 squared. 24 times 24 is 576. So the square root of 576 is 24. Here I can reduce my fractions before I complete my multiplication. I can take a 3 out of both of these, leaving a 1 and an 8. So my final answer would be 19 over 8. Looking at number 8. Again, we have 2 parts here. I have my negative 4 chilling out front. The square root of 484. Well, that's less than 576, so we know it's got to be smaller than 24. Let's try 22. So 22 squared. Multiply 22 times 22, and you see that that is 484. So the square root of 484 is 22. So we're going to multiply negative 4 times 22, which is a negative 188. I'm sorry, negative 88. The 1 just jumped in there for some reason. Now, of course, everything in the world is not perfect. So between which 2 consecutive whole numbers does each square root lie? Well, I've got the square root of 92. Well, with this one, I know square root of 81, and that's less than 92. I know the square root of 100. So it is in between 81 and 100, so therefore it is between 9 and 10. And the square root of 24. Well, that one's bigger than the square root of 16, but it is smaller than the square root of 25. So therefore, the square root of 24 is somewhere between 4 and 5. Number 5. I know the square root of 4, and 5 is bigger than 4. I know the square root of 9. It's less than 9. So therefore, the square root of 5 is somewhere between 2 and 3. Here with number 12, I know the square root of 144 is 12, and I know the square root of 169 is 13. 152 is somewhere between 144 and 169, so therefore it's between 12 and 13. Now, we can simplify radicals by taking out the parts of them that are a perfect square. So let's think about 63. I'm going to go through and do my prime factorization of 63. Take my little factor tree like we've done for years, and we go through and we say, hey, this is 9 times 7. Oh, 7's a prime number. Oh, this one can be split. He becomes 3 times 3 prime numbers. So the square root of 63 is really the same thing as saying the square root of 3 times 3 times 7. Well, anytime you have a pair of numbers underneath here, they can come out as 1. 7 doesn't have a pair, so he gets to stay inside the radical. And now we're done. This one has been simplified. Square root of 63 is 3 times the square root of 7. Looking here at the square root of 98, so let's do our prime factorization for 98. Well, I know 2 goes into it. Let's try to keep the same color scheme going on here. The 2 goes in there, and that's 2 times 49. Oh, 2 is a prime number. 49, that's not prime. That becomes 7 times 7. Oh, those are prime. So 98 is really the square root of 2 times 7 times 7. Hey, look, these two make a pair. When they make a pair, they can move out front. My 2 is left chilling inside my radical. So the square root of 98 is 7 times the square root of 2. Next I have 256. 256, if we go and look at this one, we should know by this, because we have our list of perfect squares, that 256 is 16 times 16. But let's go and use the same model that we just did right here. So I'm going to do my 256. When I separate this out, this becomes 2 times 128, because I know that 2 goes into even numbers. 2 is prime. Oh, look, I can do this again. 2 times 120 times 64 this time. Oh, look, 2 is prime. Oh, 64, I know 64. 64 is 8 times 8. No prime numbers yet. Here and here can be split down to 2 times 4, 2 times 4. All my 2's are prime numbers. 4's can be split down to 2 times 2 and 2 times 2. These are all prime. So the square root of 256, I have 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 4, 5, 6, 7, 8. 8 of these things. You group them together in pairs and bring them out. That's a 2. That's a 2. That's a 2. And that's a 2. And we multiply these together. 2 times 2 times 2. So 2 to the 4th power, essentially, which is 16. Looking here at number 4. Well, let's take my 48 here. Do this prime factorization. Well, I know that 48 is 6 times 8. I should keep our same color scheme going here. 6 times 8. Either one of those are prime numbers, so I've got to split those. This one becomes 2 times 3, and this one is 2 times 4. Oh, we've got some prime numbers here. This one, and this one. 4, he gets split up. He is 2 times 2. So I now have 2 times, I have 1, 2, 3, 4 2s, so 1, 2, 3, 4 2s, that's a 3. So this 2 comes straight down. He's already on the outside. He doesn't need a pair because he's already outside the radical. Inside the radical, they can only come out in pairs. So this one's a 2. These 2 go together. This is a 2. My 3, he's still chilling inside the radical. The ones that are left together, I multiply those together. So 2 times 2 times 2 is 8 times the square root of 3. A couple of more examples of these. Looking here at number 5, I'm going to take my 72 here. Go split it up. This one here is going to be 8 times 9, and neither one of those are prime numbers. So I can split these again. This is 2 times 4, and this one's 3 times 3. We do have some prime numbers chilling here. Go in this one. 4 becomes 2 times 2. So I now have 5 times the square root of 2 times 2 times 2 times 3 times 3. Remember, if it's on the outside, he doesn't need a pair to partner up with. Inside, we do need pairs. His 2's come out. His 3's come out. This 2 here has to be chilling in the radical by himself. I now multiply the numbers on the outside. 5 times 2 times 3, which gives me 30 times the square root of 2. For number 6, we have 216. I split it apart. I know I can take 2 out of it. This will be 2 times 108. This is a prime number. 108 can be divided up. It can be 3 times 36. 3 is a prime number. 36 can be 6 times 6. These are prime numbers. Oh, wait a minute, 6 isn't a prime number. But wait a minute, 6 is a set of pairs. When we're looking for these things, if we look for sets of pairs, we can use those to help us just like our prime numbers. So we can say that 216 is the same thing as saying the square root of 2 times 3 times 6 times 6. And as long as I have pairs under my radical, I can take those out. A pair of 6's, that comes out as 6. 2 and 3 are prime numbers. There's nothing to match them with. So that stays in here is 2 times 3. So my final answer would be 6 times the square root of 6. Let's look at 192. I have 192 here. I'm going to go through and split it apart. I know I can take a 2 out of it. So this is going to be 2 times 96. 2 is a prime number. 96. I can multiply, how about 16 times 6 to get 96. No prime numbers. So I split again. This one becomes 4 times 4. This one's 2 times 3. Well, 2 and 3 are prime numbers. And look, my 4, I have a pair. Looking for my pairs. So this one becomes negative 3 times 2 times 2 times 3 times 4 times 4. Remember, first this one can come straight down. He doesn't need a pair. These 2's come out. These 4's will come out. I'm left with square root of 3 inside the radical. I multiply the numbers on the outside. 3 times 2 times 4. So I get a negative 24 times the square root of 3. Our last one we have right here is 2,520. I know I can divide this by 10 because it ends in a 0, so let's take a 10 out of it. This is going to be 10 times 252. No pairs and no prime numbers, so I'm going to split these again. This is going to be 2 times 5 here. 2 times 5. Oh, there's some prime numbers there. This one over here. Let's see, this is going to be 2 times 126. Going to be a prime number. 126, not prime. No pairs yet, either. This one's going to be 2 times 63. Oh, look. 2 is a prime number. 63 gets split down to 9 times 7. 7 is a prime number. 9 becomes 3 times 3. Oh, yeah, and there's our last 2 prime numbers. So for 2,520, that's really saying the square root of, let's see, I have 1, 2, 3 2's. So 1, 2, 3 2's. I've got 2 3's. And mark these off as we go so we can keep track of them. So I got my 2's gone. I got my 3's gone. I got a 5 in there. And I have a 7. We go match our pairs up. So I've got 2. He comes out. I got a 3. He comes out. Inside the radical, we have 2 times 5 times 7 left. We do our multiplication. So on the outside I have 6. Inside I have 70. I left a number out, didn't I? We have all of them because inside here we have the square root of 70. Simplifying perfect squares. Looking for numbers with, square root of irrational numbers between two consecutive digits, and then simplifying radicals. As always, pay attention to what you're doing, and good luck.